ಬಿಟ್ಟು ML LM ಬಿಟ್ಟು భయలం కదా అలాంటి ఫోటో తీసా ఒకసారి ఫోటో చూపించు నేను వచ్చాననుకుంటా కదా So meanwhile, while we if I do just quick round of introduction so that we could be able to understand who the audience is. You need not to stand, just speak from where you are sitting. It's not a regular class, it's just an interactive session to understand what we are doing. Yeah, Shazan.
So, yeah, my name is Shazan and I am basically building the IoT space. More like more into the management side of the story, but building the IoT space, we are working on an interesting project that is building a snake robot, which is in the underwater domain, which is an ROV that we're trying to build now. And eventually we are planning on extending it to an AV, and that's pretty much what I do.
Hi, I'm Hamza. I'm trying to build something in the disaster response space with respect to UAVs, and that's how I want to explore this hardware domain. And that's how I'm here and looking forward to make new friends and build something.
Hello guys, good afternoon. I'm Sarita, studying second year EC in Andhra University. I'm just new to this machine learning. I was so interested to learn. So it's just like introduction to me.
Hi, I'm Manikanta from Andhra University, second year EC. And as Sarita said, I'm also new to this domain. I want to just explore this machine learning and all these things.
Hi everyone, my name is Madan. I am second year 2x4 IT. I am here to explore the various technologies in embedded systems.
Hi everyone, I am Prasanna. I am from 2x4 EC Women's Campus of Engineering, and I love working with embedded systems as well as robotics and mechatronics. So to leverage my concepts in embedded systems and microcontrollers and mobility.
Hi everyone, my name is Sharnatya. I am from 2x4 EC of FB. And I am interested in these embedded systems and things, so I want to improve my knowledge about this. That's why I'm doing.
Good afternoon everyone, I am Syed Nizam. I am fourth year computer science student. I just got curious about this is the first time attempting a workshop on the hardware stuff. So I just got curious. I work on ML. I intern in ML, so I just got curious how this hardware and ML will be together.
Yeah, my name is Rashad. I am from EC over here. I need to maintain projects on IoT and machine learning. So I need to get more knowledge from this and I will complete my project.
Myself, Sagan Arma, I am from CSE department. And I am being here because this month end we are having hackathon for them. We are planning for building a model which is more relevant to ML. So it's made me to be.
Hello everyone, my name is Rasagna. I'm almost entirely on the AML side, so this is a fun little new journey almost in that domain itself. So looking forward to learning.
Okay, looks like 5 minutes over, so I'll get started. So I'm your current facilitator for this workshop. My name is Syed Junaid. I work in capacity of product development manager in Aham. So I also have a title called Seed Ranger. So Seed Studio is the company which is sponsoring this workshop. Basically, we have the hardware which is being using in this particular workshop will be sponsored by TINYML. They have given us, so we will responsibly use and you will return back to me. So be careful while you are using that particular hardware. It's very small, a stamp size device. Okay. So we'll get started into the workshop. So when we say basically TinyML, you might have got to understand the word itself is being telling TinyML. So which works on top of a microcontroller or a hardware which is basically an embedded device. Usually when you say ML, what happens in our picture is that like we need a large GPU or a CPU which could be able to process this data and then to be able to take us to the next extent. So what happens in TinyML is that like you build the model how you build in regular ML, but you have a couple of processors or like preprocessors basically. You could be able to convert that particular model into an embedded enabled model, and then that particular model you could flash on this particular device. So we'll just go with the basics. So let's yeah, when we see the gambit of artificial intelligence, when we say that like whenever we talk, what we listen is that like machine learning, deep learning, and whenever we listen about AI, the buzzword which we think, what is AI basically? What do you say? What do you think as an AI these days? Okay, substitute intelligence are human being. So how you could be able to simulate the human intelligence in the systems? What are you doing basically? You're giving some data and then you are training multiple inputs from all of people, right? So what happens is that like what you are doing is like basically you are not doing artificial intelligence, you are doing machine learning. What you are doing is you are giving a sample set of data to the machine, saying that like you identify these features on this particular data set, and you are mixing with some other data set which you have and the already trained data into this particular thing, and you push it into the funnel. Finally, what happens is like with the confidence level, how the weights are being programmed, that particular image or that particular specific object or something which you are trying to find is being identified in that particular image or the data set which you are providing, and it is inferring a meaningful information out of it. So when you say deep learning, so what happens is like deep learning is much complex, where it works in a fashion of how our brain works basically. What happens is that like you have the trained model where you could be able to have the consciousness coming into the system in such a way that you have different algorithms there available where you could be able to random forest models and like stuff where you could be able to derive and define, like you could be able to quickly understand, like it's much faster than the machine learning process actually. So ML versus traditional programming. So first what you do when you want to do programming, you try to create an algorithm or a pseudocode. You understand what are the requirements of our client or what are the requirements of ourselves, how we are going to take it forward. So then what we will do? So traditional programming, you take input, you input into your algorithm, finally you will find out what would be the output basically, right? And then, so when you say training machine learning and creating model, so you give inputs in the form of data sets, and then what you expect output data or data labeling basically. Together when you do this particular thing to be able to machine, what it does, like it gives trained model output, right? So then interfacing machine learning with the model, what happens like user input and the trained model, and then you find out how much confidence is that particular image or probability of that particular thing matching, right? So usually machine learning is human learning, if you say in infographic. So what happens when you are baby, the parents will tell you this is a dog, this is a cat, and this is the thing, and your brain starts understanding, and its neurons get developed, right? And then what happens, baby usually use a pictographic image from the brain and it starts identifying this is a dog and this is a cat. Whereas similarly in the machine learning, what happens is like you have a computer, you are as a parent to this particular system, you start training it as this is a dog, this is a cat, and you are marking its features. And then finally, computer does the activity same as what it does in the brain. So where machine learning can help us, basically pattern recognition is a major part which where we are going to identify. Either it could be in the form of numerical data, or either it could be in the form of machine like image pictorial data. So what are the limitations of machine learning? So machine learning algorithms are powerful tools, but they can have the following drawbacks. They output estimates and approximations, but not exact answers. With the 100% confidence level, it will not say that like if I show Apple and train it as Apple, and then you bring another Apple which is similar to it, but it will say with the confidence from 69% to 80% or 90%, like almost nearby 99% is Apple, but it will not say, it will not confirm, right? And also it requires expensive computational power to run basically. And unless you have the computational energy, you couldn't be able to do. So, and also training data can consume, and it is also expensive because you have to hire those GPUs and stuff. So, what is embedded ML? So, this is a journey how it started actually in hardware. So, they have started as cloud ML, and they could be able to use that particular like VNNs and large models up to 60 to 32 GB, 10 million parameters it could do on teraflops and stuff. Then it transferred in 2016 to mobile ML, where CNN Lite could be able to come into the picture. And you have constraints of the memory resource in that, like you could have only up to 8 GB RAM, and gigaflops only it could be able to do. And it could process the data like pick audio, clicks, GPS kind of a thing. Whereas in TINYML, in 2019 it got introduced, and it started as CNN Micro, the flavor it's been running on that, and severely constrained resources, and you started at 16 GB RAM in the cloud, and you got up to 8 GB RAM, and now you have only RAM in KBs. 100 KB. But you are trying to achieve what the actual model is trying to achieve, right? Where with the TINYML, what happened is that you could be able to use resources on the go, and you could infer things on the edge. So how many of you know edge computing? What is an edge computing? Okay? What? Tell me, it's not, I'm not going to award you marks. You can search on Google, some people might be doing that already. See, basically, edge computing is that whatever happens, like let's say you ask a question to, don't worry, everybody is going to get that same message. So it's going to be a ringtone festival for some time, because Diwali is nearby, so they are sending a message saying you are in a prone area where you could be able to see fire problems. So call 112 or 100 or 102, it was the message coming from that. Huh?
How does iPhone get it?
No, I got first. So that's what I'm telling you. Fine. This is how the technology is improving. So they could be able to triangulate us from the cell towers and stuff, and they're sending us information, right? Fine. We'll come back into the picture again. So the thing is, what happens when we say edge computing? You have processing. Let's say you have several sensors connected to your device, and finally you are. Usually, what happens when you send a request to a server, or when you request some information on the browser or something, You hit the request, it goes to the server, it fetches the data from there, and it comes back and display it on your screen. And it is storing the data on the cloud. When it comes to edge computing, the processing happens on the edge. Let's say the server which itself you are using, that will have internally everything inbuilt so that the data which is coming in will be computed and then you could get results on the same server side actually. So, whereas in TinyML what happens, the benefit is that this is an edge computing device. What happens is that like you can connect sensors like cameras, IR cameras, audio input devices, accelerometers, and sensing the physical data, like physical world, by 95% it could be able to achieve actually. So IoT 2.0. Why IoT 2.0? What happened? Can you guys identify a couple of devices in this particular screen? What are these?
Electric toothbrush, smartwatch, Apple.
So everything is connected to your mobile phones or connected devices. These are called connected devices. So what happens with these devices is that these devices are, you are sending a request to either Google Home or Alexa or Google Assistant. It takes the data and then it goes to the server and comes back with the request response, like what did you ask it, it will deliver you the data. And just it is storing the device data on the local thing, like at Google Nest, it's a basic home automation tool where you could be able to have like controlling humidity and temperature in the home. So in this, you have latency issues, privacy issues, energy issues, and the bandwidth issues you have in these devices. So whereas when you come to the TinyML, so tiny machine learning is a field of intersection where embedded systems and machine learning come together. So that's the essence of what we are trying to do. So when you say the tiny machine learning, so currently it is fastest growing field of ML, and you have hardware, algorithm, software on device sensor and analytics. It's happening everything on the device side. So which is low power consumption and always on ML. And it's a battery operated device basically. So benefits of edge ML. So you have innovation, you have privacy, power, fast efficient, and reliability, and the latency issues are not there because it is not getting there to the cloud and coming back the request. Requests are happening on the go, on the edge basically. So it's something like that, hey Siri, hey Alexa, or just okay Google, you get started things actually. So you can see that like Adidas has come up with some kind of a device on their insoles basically, which could be able to identify like kicking, penalty kicking in, passing and dribbling in the what do you say when you do basketball playing actually, it could be able to study while it's being played. And the data which is happening is coming onto the screens of the judge so that he could be able to get results on top of that. So TinyML is all about the sensors and data and intelligence. So how you could be able to do, you have motion sensors like gyroscopes, radars, magnetometers, accelerometers, and acoustic sensors like ultrasonic, microphones, geophones, and vibratometers, environmental sensors like temperature, humidity, pressure, IR, etc. So when you say that you can see on the screen, like there are several kinds of sensors available, right? So they could be able to get the data, lots of data coming to you actually. So what's happening actually? Like what you will do basically. So this is all you could see from the news basically. You can say TinyML is the largest machine learning tech having an outsized business impact. You could also read machine learning at the edge, TinyML getting big. So these are all like 2021 articles basically. So the distribution intelligent spectrum. Now, we have an ultra low power device with sensors, and we have the intelligent devices which everybody has with them right now, the mobiles, and we have gateways, and then we have on-premise servers, and then the cloud. So when you say, so the thing is, edge AI, you could be able to perform on these all gambit of spectrum basically. Due to the existing constraints, these devices are located at extremely left end of the distributed intelligence spectrum. So on the right side you have the cloud, which is a high-hanging fruit, but on the lower hanging side you could have the TINYML which you could be able to use. So HMI solutions can be used in these particular fields, like whereas you could use wearables, spaces, where in the industry areas like motors, power grids, and logistics, you could say asset tracking and stuff. So when you say wearables, so you are very confident now these days with voice commands, health predictions, activity detections, gesture recognitions, and you have acoustic event detections. Let's say a big sound comes, it could be able to record and understand what's happening. So similarly, like when you say in the spaces, what happens is like you have several appliances available, and they are in different conditions in different states actually. You keep on health monitoring each stuff, it is a difficult task. If you have an inbuilt assessment system in the machine itself, where it could be able to automatically read and understand what's the status of that particular device actually. So with that, what happens is, let's say, when we come into this room, we were having the HVAC off, right? So if we have created a model in a way that like detect human beings' presence in this room, once you detect several heads, let's say 10, 15 count, automatically HVAC should start. So that kind of small problems you could say, once the room is getting empty, automatically it should be able to shut down. So usually, like this kind of a solution, if you want to create, how much it's going to cost? And obviously, but I'm checking with you guys is how much would be the cost basically. What would be the cost of doing something like what I was anticipating? What we used to do before and what we can do now. If you can just think, because I just don't want to do a monologue. This is a workshop where I will need people. 2000, okay. You have to speak up bigger because the thing is 2000 you can't do anything. And you should have some service like something like TeamSpeak or Link or something, somebody service provider is maintaining it, right?
It's 5,000. Because 3,000, 4,000 you get a camera.
Any other choices? Which can charge in us 2 mobile numbers. Okay. Yeah. Any random thoughts?
So
Yeah.
what will you use totally sensors with cameras and so you will do like conversion with this TINYML with that and
No, the thing is, I was asking before TinyML. When TinyML doesn't exist, what would be the cost?
so we will take some other
So you guys didn't get my question specifically. I was asking you guys, when TinyML or something similar to it doesn't exist, what would be the cost for the solution which I was asking you? I was expecting some range of 18,000 or something. Because I have a bill of material which I could be able to use basically. Sometimes like some fancy guy wants to have a Raspberry Pi into the system, then we should add another 5,000 rupees. So with the TinyML, you could do the same thing probably by 2,000 rupees or 1,000 rupees. So with the advancements in the recent time, like the microprocessor architectures and algorithms, it is possible that now you could be able to do embedded machine learning, which is called as TINYML right now. So there are some major advantages of deploying ML on embedded devices. These are the key advantages are neatly expressed in the unfortunate acronym BLERT, blur. Okay. So bandwidth, ML algorithms on edge devices can extract meaningful information from the data that would otherwise be inaccessible due to the bandwidth constraints. What happens is that, yeah, get it? Yeah. ML workshop, yeah, get it. So latency, usually latency causes a huge problem. With milliseconds you leave, because data gone, it's not recorded, you will miss a huge chunk of data. So latency issues are there. So on-device ML models can respond in real time to the inputs which are coming in and enabling applications such as autonomous vehicles, which are not be viable if independent network latency. And similarly, economics, by processing the data on the device, embedded ML systems avoid the cost of transmitting data. Because let's say, usually what happens is like these data, whenever you have a connected IoT device, it usually requires a platform like NB-IoT to send the data. So usually, what's the cost of 1 GB per day, or what's the cost of data transfer these days actually? Typically. Not 1 Gbps I'm asking, but like data consumption, let's say that I'm talking about transmitting data over a network basically and processing it in the cloud. So usually now the cost of the bandwidth come down, but when you are specifically sending data in chunks of numbers, like a lot of numbers are coming out of your system and sending it to the system, like currently Airtel and IoT is offering something like 500 MB for 5,000 rupees or something like that, something like that, those rates are there. And also you have reliable systems where like the systems controlled by on-device models are inherently more reliable than those which are dependent on the connected cloud. Something goes wrong, your model is not accessible, you will not be able to get the results actually, right? And similarly the privacy, you have everything in your control, hopefully. So when the data is being processed on embedded systems, it is never transmitted anywhere to the cloud, or user privacy is protected and there is a less chance of abuse basically. So how it works? So you have training data and then the model for training. Usually what you do for the ML, that's a regular process. And then you have interpreters where you have model and prediction and the test data. So from the bottom it's coming up. So it's festive season, so we can't do it anywhere. So the machine learning model can be created and trained, will be done with the help of powerful machines which run ML. And then after that, the model inferencing will be happening on the TinyML device of our choice. So according to which particular platform which we are going to use, let's say currently the hero of this day is Seed Studio Sense. Basically, it's a Zio 32 Sense is the device which we have. So we would be able to convert our model inferring with that particular thing. Okay. So, how many of you know what's an ESP32? So, or else like, how many of you know what is Espressive as a company? Yeah, Espressive is the company which makes this particular chipset, which is called ESP8266 or ESP32. These particular devices have come to rescue humanity, you can say. What happening in these particular devices is such way that the costs are very less, and also you have the compatibility and adaptability of having a Wi-Fi radio on it. The Wi-Fi radio, you could be able to use it as an AP, as an access point, or as a Wi-Fi receiving or transmitting device, basically. And also you have Bluetooth connectivity with them and the ESP32 together. So these two methodologies which we have. So now we have Cryo ESP32 S3 Sense with us. I will be giving you one unit shortly. So I'll just try to make you to understand so what would be the picture which you are seeing, what would we call this basically? Okay, any names?
Pin diagram.
Yeah, pin diagram, okay. Yeah, pin diagram, or you could say, yeah, so how many of you know what stands for what? So what's the 5 volts here? Okay, DC and ground, and then we have
3 volts.
huh? This is how many volts actually? 3V3, 3.3 volts. And when you say B,
Digital pins.
okay, you can use thing is you have digital DO till D7 and also AO to A8. So you have 8 digital, 10 digital, 8 analog inputs you could give, or 10 digital output inputs you could give actually to this device. What's a typical Arduino Uno, if you say, as a development board? How many? 6 analog inputs?
13
13 digital input outputs you have actually. So then, what's the form factor of that, and what's the form factor of this, if you would be able to see? So this would be of this size, of 150 coin size, and you have the Arduino of this size basically. So with this, what's happening is that you could be able to reduce the size of your device footprint basically. So you also can use these particular points as touch points. You have 7 touch points you could be able to use basically. So you could convert them as 7 touch points. And you have SDA, SCL, which is you go give the input basically. Where you could connect the TXRX for the receiving and transmitting of the data. And you have the camera, which is getting connected as with a Molex connector basically. Will not have any jumpers, just you could be able to snap on the camera on top of this particular sense device. So this is how the device looks actually. We'll have a small introductory video.
And today we're going to be working with an ESP32 camera board. Now when you think about ESP32,
This is a whole long workshop, but I'll just quickly take you through this.
you need to insert a Schottky input headed by the USB-C camera module. The top of the board is dominated by the USB-C connector, which provides both data and power connectivity. Most of the pins of the Shao ESP32S3 have multiple purposes, and this board has the same pinouts as the other members of the Shao family. Note that the 5-volt line is both an input and an output. You can use it to power the board, but you'll need to insert a Schottky diode in series. It can also be used as an output from the USB-C connector. Note that there is no output here when the board is being powered by a battery. The 3.3 volts is an output from the board, not an input. There are a number of connections on the bottom of the board as well. There are additional connections for the USB-C bus. The connections for the battery are on the bottom of the board. There are a number of connections that come from the board-to-board connector, and there is also the thermal pad where you can measure the temperature of the board. The camera module has an additional 2 GPIO connections. When discussing the Shao ESP32S3 sense board, inevitably the comparison with an ESP32 cam.
Guys, please be careful with these particular devices. We
As
have
you can
to
see in
be
this chart, the Shao ESP32S3 sense board has in most cases the same or more features than the
open it
ESP32
nicely so
cam.
that I
The
will
one
have to cover.
exception seems to be the white flash IDG, which the ESP32 cam has, and which is not included on the Shao board. The Shao ESP32S3 Sense is packaged with a stick-on antenna. The onboard camera can be upgraded to a 5-megapixel OB5640 module. You can also buy the Shao ESP32S3 Sense board separately without the camera module. So now let's start using the Shao ESP32S3 Sense board. Now, one thing I've always been amused by with CDMA products is the way that they package and they look like something that you find at a checkout stand.
So you find it as a tablet, right? So open it up nicely. So you have to, heat things, keep them back inside the cover. Okay. You are not going to use the heat things. You are not going to use these things or jumpers right now, so you have to keep them back in the cover. So you will be using, there is a flexible antenna that you keep outside. That's a flexible antenna, I'll just show you guys. So we have, so these two things, right? So these two are the ESD safe pouches. While handling, unless I tell you guys to open up those two things, please don't open. And you have this antenna. This is the antenna where you need to stuck, I will tell you. So you can see here, this is the antenna, and this is the board, and this is the camera board actually. So just you have two things, right? In that, like the one with the USB-C cable. If you guys can just open it up, just hold the device like this. Whenever you hold the device, hold it like this. Don't touch the bottom base. Okay. Whenever you want to touch the device, open like this. So everybody unpack.
And in the supermarket, it's come with any header pins soldered onto it, nor are there header pins in the package, so you're going to have to solder some pins on yourself. As you can see the board, you can see its main features, the USB-C connector, the antenna connector. I need a couple.
So here you can see there is a white color pin, right, in the corner actually. This is the antenna connector. Okay, you guys can simply snap that particular antenna on top of it. So be careful while you are snapping it, just look into it that you don't break the antenna or break the connector. Just align it properly and then push. Then you'll hear a snap. Align it parallelly. Just do it. What I told you, how to hold it and how are you holding it. What? Did you broke it? Prasanna failed and she has passed on the baton to someone else. Huh? Yeah. I didn't get your name by the way. Joseph, please, while you're handling, don't touch the bottom, it's just easy. Hold it this way. Because why I am telling you guys, this hold on the corners is because we are electrically charged. We don't know while what we do, while we come in contact with glass or steel railings and stuff, we may get induced with static electricity. And that static electricity goes from 5 kilovolts to 15 kilovolts of potential, and it can burn that specific thing like anything. Yeah, that's what I'm saying. So that's parallel. You might have misaligned. If you guys are not able to snap it, just let me know, but don't break it. Okay, everybody is ready? So here you can see on screen, everything is ESP32. You have ESPI, ESP32 CAM, and the SIO with us, ESP32 S3 sense. So you can see the form factor, how they are different actually. So how it is so small and like good to see actually. The next step which I am going to tell you is take out the camera module. Okay, you can see a Molex connector on the back. Okay, and on the side also same Molex connector will be there. The male part. So if you can look, you could be able to easily snap them one on top of other, and then you have this. It should map like that. You have to put it reverse. You have kept it reverse. Be careful. It should align to upwards actually. And then this, take this is the connector, align here, do a snap. Towards up, reverse, you are doing reverse. The image which you see on the screen, that's how it should be. Where is your focus? Everybody is ready? So now we have our device ready. So then we'll take you to a platform which is called SenseCap. I'll show you the screen. SenseCap. it's sense craft, not sense cap. I'm taking it wrong. Everybody these days having same name, similar names. Yeah. So we have to go to sense craft. So there you guys might find something like right now. So SenseCap is the company which makes this particular platform, but the thing is which we need to go here. Okay?
Is it SenseCraft or Cap?
No, if you go to sensecraft.seed.cc, then it will direct you like right now to sensecap.seed.cc. Okay? So you can see on the screen the URL if you guys are not. Thank you. Are you guys able to log in? So once you log in, you can see the screen like this. You'll get a dashboard. Okay. Are you guys on the screen? So usually when you buy an Arduino or something, what happens, like if you want to deploy something on it, you need to install the IDE and then you start going from the examples, right? Whereas in this Dio series, when we go work with SenseCap, you can directly control the devices from here actually. So login completed. Sorry guys. We will change the address. Is sensecraft.c.cco. Okay. And /AI you have to. Once you register only. Once you register on the platform, go to the sensecraft.c.cc.ai. Can you guys come to this platform? This particular. Sensecraft.c.cc. Everybody is ready? Okay, then take your USB-C cables. Everybody is ready? Done? So then take pre-trained models. So now we are not in a stage to write the model right now. So we'll just explore pre-trained models which are available. Okay? And then we'll click the supported device as Zio ESP 32 cents. So let's try something like face detection. So the simplest thing what you can do is like once you go to this page, pre-trained model which is already there, click on the deploy model. And so you'll get to see all this stuff that what we have done till few minutes back, and then you will click connect the device. Once you click the connect the device, it will ask you, this is the face detection model, whether you are confirmed to deploy or not. Click confirm. Then you will get this prompt. It says like USB JTAG or serial debug unit, COM port 10 or whichever port it gets enabled on your device. Simply click connect. Once you click connect, it will start downloading the model file, flashing the file, and and then it's restarting the device. So now, let's say we have Varma on the screen and Varma's team on the screen, I can say. So it says with 55% confidence, it's saying that there is a face in front of it. Let's do this. And let's say if you want to do some kind of action, basically, go to the configuration, you can go to the output, you can trigger something. Like let's say, click trigger object face, and then the condition of something like greater than. What's the confidence you're looking at? Let's say confidence level 50 or 58, I said kept. And then if I click confirm, it one condition I have given, and then if I click light up the LED and then send. So now the action has been sent. So now what happens is that whenever the confidence level of the model gets above 55 or something, then you can see another light on this particular device glowing. You can see there is a glowing device, LED. No, because there is light, so that's why you focus on the front guy's face. Alan, can you take a picture of people with their consent to show what they're doing? When they're playing, like, you click the Hamza doing what he's doing. So, what do you guys understand with this particular activity, what we have done right now?
No more coding code.
Yeah.
Like cloud.
It's happening on the edge, on your browser. Just you are grabbing a model, somebody already nicely made for this particular device, you could be able to run and see the action basically. Yeah, you can try that. Anybody facing trouble? What happened? Okay, just go to pre-trained model. You are there, right? Go on left side. There you will see supported devices. There will be our board, SIO ESP, whatever you would like to try. Click that time. Deploy. Go down. Connect the device, and then the last kind of edge, confirm, click that particular COM port, you have a connected device. Yeah. You lost your internet connection. In the middle?
Not in the middle. It just asked me to check the connection.
What did you do, man? You are connected? You just You have to move the light. Right. The data driver is a JavaScript. You have JavaScript enabled. Just go to page. But you can you check USB TTL the devices are connecting and plug out? Could you hear some sound or like could you see anything if it's connected on your device? Devices, can you check the devices? You have done it? So you can try another model also. Check whichever model you would like to try. Like let's say you want to check your friend's emotion and stuff. Go check. There is another pre-trained model available already. Emotion classification. You can keep or you need not keep. You just go to the output if you want to trigger something. No, not necessary. Go to the output and then when you click, you want to glow the LED, right? Keep that and then you put the trigger in the conditions and that's there. There you can find, if you want to find the phase, if the confidence level is higher than 50, you want the LED to be. Just keep it that way. And set. You can see, yeah, but once you show the phase, you can see the light is blinking. Take last. General election, there is a bias. There is a model biases so it is protecting everybody as a male. Oh, this is not the face. See, you could see the device log on the extreme right hand side. There, whatever the device is inferring, you would be able to see in the notations basically. So the inferences are happening in that way. Whenever you do particular activity, whatever it is coming through and it is processing and the log is coming. So each inference time interval you would be able to change. And then you could slow it down. You can set the weights basically with the confidence levels where you would like to have like what's the inference confidence levels and stuff. Okay. So how many models did you try so fast? Okay guys. Now you played enough with the already trained models. Now let's train a model of your own basically. So on the same platform, when you go there, like once you have your expansion board, it's connected to the PC. So you go, click first training. On screen next to the pre-training models, you have the training. So you have something called classification and object detection. Right? Once you click training, so everybody on the screen. Then you have, once you click the classification type, then you can see the screen something called color classification data. And then you have on this right corner like your laptop camera, or like you can select from the drop down. You select the Shadow ESP32S3. Are you following the? Go click training, training type, classification. And select the camera from webcam to shadow. Connect. Accept it. So you can click class 1 and then hold to record. Whatever you want to do, somebody has done class 1 and 2. Class 1 and capture pictures each over 1 over 10 images will be fine. More or better actually. Whatever you want to do, capture the same image 10 or more times. One thing you could do, like once you see in the class 1, hey, use the shadow camera. Okay, you can do whatever you want. Yeah. Hey, you can either choose your webcam and do record. That's up to you guys. Class 2. In class 2, you give another image. Whatever you want to do. Or like you can another object or anything like that. It's up to you. Guys, did you get my point? What I was trying to tell you? Just do it. Okay, nice. Go to train. Start training. Training completed. Okay, then you can deploy. How are you training actually? How are you training? How are you training? You can see that you have to train us, like you have to show the guys, show whatever you do in the train model 1, model 2. You are just getting random fields in the tab. Here and there and registering. You capture. Where is that? Which will be there? You have to click. There are you have to click sample trends.
Actually, all it did, sir.
Huh?
All did it again.
Where we can see in the class. Class one is empty.
Okay, it goes all. I did it deleted. Second Friday.
Huh?
Second Friday.
Second time. So click on the class and correct? This class is from where it is taking the
This mouse, like we trained this mouse, this student.
Huh?
We trained for this mouse.
But that can be detected as a mouse. Can, but it's not the same image, but it's classified in the same category, right? That's what you are doing, classification. You are not doing matching, right?
So training is
phone, let's say, I'll show my phone. You trained it in on the terminal or well, see, that blue light is getting empty here. Make it red. You can classify it as now. But it is not happening so much. It is not, the confidence is not going up. Reduce the confidence.
So after training, what you have to do?
Deploy.
Deploy the device.
Yeah. Nicely labeled. Manikanda without face, without phone, with phone. You almost took 100 samples. But you are doing with your laptop camera. You might just try out.
What if we train different kinds of mouse?
You can try it. It's with you.
Yeah.
I'm going to take this particular step only after some time. Before you can try what you want to try.
We are there in that.
Yeah, will do. Shazan. Shazan. I need you to fill the form. I'll show you your code.
Can you take one testimonial from
Yeah, you can take it.
my test? And also TINYML. Say that it's a TINYML workshop, thanks you.
You'll go to China.